Alright folks, thank you for joining me back outside with some more beautiful May weather. It's gorgeous out right now. And I'm going to bring some interesting ideas with water. Today actually we're going to be talking about water, the wonderful properties of water, and we're going to show you that with a few different smaller activities. Again, some of them may be small and simple, but as I said in the previous few sets of videos, don't overlook the small, simple videos. You can gain a lot of insight and information just from something that you're able to manipulate and see clearly. And then maybe we'll have a few more complicated experiments too. Alright, so let's get started with the first one. The first one, we're going to need a few things, and I'm going to be doing this outside over the grass. You can do this outside if you'd like, or you can do this inside somewhere where it's okay to spill a little bit of water. So what we need is a little bit of water. I have a nice jug, tap water. I have a little bit of food coloring here. You can choose whatever color you're going to like. 2 glasses. I'm using 2 identical glasses. They're glass so that you can see through them. We're going to use a towel in case things get messy. And then finally, the important part is a piece of yarn. Alright, this yarn is pretty fluffy and thick. It's kind of the yarn that you want to use. You may have to, if you have a few different styles at home, you may have to experiment with them. But this is the yarn that worked best for me. Yeah, worked great. Alright folks. Alright, so here's the yarn that I'm using. As you can see, a little bit fluffy, a little bit thick, but it's still pretty small. And I'm just using a little bit of food coloring too over here. Alright, so the first thing we're going to do to build this mini experiment is we're going to take 2 cups. We're going to fill one of them with water. And I'm going to put a little bit of food coloring in so we can see the water. And then we're going to be able to transfer the water from this cup to this empty cup over here. Alright? And we're going to do that with string. Alright, so let's get this started. I'm going to fill one of them, just the left one, up with water. Alright. Let's put a little bit of food coloring in so we can see. Favorite color is red. Let's do some red. I'm going to use my finger to stir. Maybe you should use a spoon at home, but... Alright. And then what we're going to do, we're going to wet this yarn. So I'm just going to place it in like this, get it nice and wet. And I'm going to do the experiment actually standing up over the grass so I don't make a mess. Alright, now that we have our yarn nice and wet, what we're going to do is we're going to take the piece of yarn and we're going to connect it between the 2 cups. Again, this is filled with water. This one has nothing in it, like this. And we're going to have to set this up maybe beforehand, and then I'm going to show you the way the water is going to transfer. But you want this side within the water fully submerged. And then how you can do this simply is you take maybe a finger or 2 with the other side of the yarn that's not touching the water, and we're going to touch the side of the other glass like this. Okay? You can see here I'm just holding it with my finger. And when you want to make sure, as we stand up, you're not going to want the yarn to touch this lip of the glass right here. And then you're going to use the finger on your other hand to hold the yarn on this glass. So if you could take this like this, you could form a little bit of a bridge between the 2. So now we have our yarn pulled taut, which means it's nice and a lot of tension between the string. And what we're going to do is you're going to take the glass filled with water, you're going to lift it above the other one diagonally, and we're going to transfer the water over. So check this out, alright? You're going to slowly tilt it, keeping the yarn very, very tight. Lift it above and diagonal, and you're just going to slowly pour, alright? And we have this in red so you can see the water transfer over. So I'm doing it slowly now. Then if we increase the speed, there's a little bit of water dripping, excuse me, but you can see the water flow down. And depending on how you hold each glass, it'll help it flow better. And what you don't want to do is you don't want to do it directly over like this. If you do it directly over like this, it might just pour in kind of simply. I think that's a little too straightforward. I think it's cooler if you can hold it sideways and do the same. Alright? And try, like, with my left hand, if you change the orientation a little bit, it may flow better or worse. So just try whatever you'd like. Alright? So this is a good speed for me. Speeding it up now. Looks like fruit punch. I'm getting thirsty looking at it. All right, I'm gonna try to do all the whole cup. Looks really cool. I got it down good now, so I'm not spilling too much, but it may take a few tries to really get it right. Pretty neat. All right, folks, pretty neat. As you can see, I have some red fingers left over from mixing the food coloring. Maybe I'll claim this now. I know green thumb means that you're a gardener, so red fingers means you're a scientist, right? Yeah, so we're gonna transition to a second mini experiment, but before I do so, I just like to mention that when you're doing this, you don't want your piece of yarn to be resting a lot on the rim. You don't want it resting on either rim of the glasses, which is why we had it on the opposite side like this, so the yarn would come in. You don't want it to like rest on the rim like this. It's gonna not allow the water to flow properly. I just wanted to mention that quickly, okay? So let me put this to the side, and we can get started with this water experiment, all right? So this one's a bit neat. You just need a few things. I'm using a glass. You don't need to use a glass. You can use anything that holds water, and we're gonna be using a little bit of water because that's the names of the experiments. A magic marker or a pencil, anything to draw with, a small piece of paper, and we're using a few different objects, okay? So the first object is something drawn on that sheet of paper, and the second object is this little thing right here. All this is two pieces of cardboard paper, a cardstock, that we have taped together. They're two separate colors that meet at this line, and we're just placing it on this material right here. It'll make sense in a moment. So what we're going to be talking about here is actually refraction and the way light interacts with water when it passes through. So what we're going to do to begin is I'm filling this glass up about halfway. We're going to be placing this in front, and we're going to be looking at how these two sheets of paper and something drawn looks at behind the source of water. And this is what I mean with things that are very simple. This just requires a little bit of water and a couple pieces of paper and a magic marker, and it's actually a pretty cool effect. All right, folks, so I had drawn a few things for you. The first thing I drew was a number 5. All right, pretty simple. Familiar with these. A number 3. I drew also a circle or a 0. The last thing I drew was an arrow. All right, so we're gonna see what happens when we place these images behind the water and see how it looks for you at home. So let's start that out now. I'm just gonna place this on top, these scissors on top so it doesn't fly away. So we have our arrow right here. I think we can see it. For you folks at home, that points to your right. Let's see what happens when we drop it behind the water. All right, let's see that one more time in case you didn't catch it. Flip directions, huh? Pretty neat. Let's look at some of the other shapes. All right, let's start with the 3. So we can see the 3, Grace?
Yep.
Yep. All right, let's drop it below. Pretty neat.
Very
We'll do it one more time for you. All right, let's try the 5. 5 looks normal. Yeah. Drop it below. Opposite. The one last thing I wanted to show you was a circle, and I'm curious, do you have any idea what's going to happen to the circle when I place it underneath the water? Let's find out. Granted, this isn't a perfect circle, but imagine it was, all right? Nothing, right? Nothing too much. The reason why is it's usually something that should be that's not very symmetric. Like a 5 isn't really symmetric, you know? But a circle is pretty symmetric. So you'd imagine with these shapes over here and these numbers, they're flipping opposite than they're originally pointed. But when you flip the circle, nothing too much happens. So I thought that was pretty neat. All right, folks. So I have simply this yellow and black combo of 2 sheets of paper, and let's see what happens when we lift this paper up. All right, it's right now, much of it is behind the water. and we lift it upwards. Flip it back down. All right. Pretty neat. I thought it was cool that we were able to actually flip the images, all images that we had, to the opposite direction just by placing it behind water. So keep that in mind. Maybe think before I explain it later at the end of the videos, after all these mini experiments, I'm going to explain what's going on. As you're seeing the other experiments, try to see what's going on. Why do you think that these images are flipping? Some key things to think about is water, light, and how light's going to react when it passes through water, okay? Alrighty folks, so we have a few more interesting water experiments moving forward. Excuse the bird, I don't know if you can hear the bird, he's yapping away over there. But some of them are a little simple, some of them are a little bit more complicated. So let's get started with just a simple one, I think, moving forward. For this, all we're going to need is plenty of water. I'm using a little bit of a glass jar, some type of old card. This is like a Speedway gas card, whatever. It's like a gift card, something you're not going to use again. I'm using some change right here. This is some change, and this is like a small magnet, just something circular with weight to it. All right? So the ideas that we're going to talk about, and again, I'm going to explain this later at the end. I think you should, while you're watching this and trying it yourself, think about forces, think about water, think about surface tension. I've mentioned that in the past before. So I think the first thing to look at is what happens when you don't do the experiment right. So normally, right, if you just take a card like this, you place it on the rim. If you try to balance something on the other end, it falls. Pretty simple, right? Again, think about forces. You know why something's not going to fall. But let's try to manipulate the properties of water so that we're able to balance. All right? So we could balance this right here. All right? So how we're going to do that is we're just going to fill this with water. And I'm going to fill it all the way to the top. Alrighty. Oh, I'll put a little bit on the side, that's okay. Right to the top like that. Let's give it a little bit more, a little bit more. Alright. If it overflows a little bit, that's okay. And then you're going to take your card. You're going to place it over the top. And again, if it overfills, no big deal, no big deal. This is why I'm doing this over a mat outside. You can do it over, somewhere where if a water spill happens, it's not too big of a deal. Let's try it now. Something's just like that. Filling it to the rim with water. Let's see what happens. Nothing fell, huh? Let's try another quarter. Let's make this 30 cents with a nickel. Oh, it fell. But we can try this again a second time, and it was pretty neat that we were able to stack a few things on top. All right, I'm going to try it one more time for you. Maybe I'll start with the lighter one, then we can progressively move up. So we're going to place our card like that. Let's put a dime on, 10 cents. 1 penny, 11 cents, plus 5, a nickel, 16, 25, 21. Pretty neat, huh? We're able to balance all these things, even that, just by manipulating things such as forces and surface tension with water. So I thought that was pretty neat, and we can take these things off, like so, and you're good to go. Alright folks, I thought that was pretty neat. For this next mini experiment, it's going to be a callback to an experiment we did a few weeks ago. If you remember, we had filled this mason jar with a little bit of water, and we had this cap. We took the flat piece off of the cap where it's just see-through, right? And then we placed this mesh, and this is a mesh actually that you use for the screen on the windows, and I can place it against this paper card right here. You can see the small holes. If you remember, we placed this over in between the mason jar and the cap. We flipped it over, and if you remember, the water actually didn't even pass through because of things like cohesion and adhesion. We're going to expand on that a bit, okay? And we're actually going to use a material that actually has thicker, wider holes. So if you thought these holes were small and maybe it made sense, let's try it actually with these bigger holes, because for me, I didn't even believe. I said, there's no way that's going to make sense, but it actually works. This material right here is, this is like the bag for like onions. If you buy like a 5 or 10 bag of onions, this is that material, the red-orange material. Other things we're going to need is we're going to need a little bit of water. All right, I have a jug of water. This is a 1 liter plastic bottle that we're using. Some few other things is this is like a hairband. I'm using, again, like an old gift card, old plastic card, a funnel to pour the water, and then we're using, these are toothpicks. These ones are extra long toothpicks that we broke in half, but you can use regular size toothpicks. Those actually will work better. Okay, so it's going to be a similar idea, but we're going to expand on it and add a second part to it because it's pretty neat. So what we're going to do is we're going to fill this with water, okay, and we're going to do that using the funnel. You're going to fill it all the way to the top, so much that it even overflows a little bit. So let's do that now. All right. Pour it in nice and fast. All right. Maybe do this somewhere where you can make a spill. All right.
John, do you want to add maybe some food coloring so we can see this better?
Yeah, totally. Yep, sure. Good point. We'll do that right after this. So, before I fill it to the top, that's a good point, Grace. Thanks for reminding me. Something else you're going to need is a little bit of food coloring. Let's put a few drops in there. Red, again, I love red. You can still see it on my fingers from the other experiment. I'm going to stir it around. At home, you don't necessarily need food coloring to see it. You can see it pretty well, but for the video, it's good for the food coloring. Okay, and we're going to fill this is into the top. We're going to fill this right to the top. All right. You can overfill a little bit. No big deal. Oh, yeah. All right. So now what we're going to do is long story short, you're going to take this mesh and you're going to stretch this over the surface, okay? And you can hold it there for the rest of the experiment with your hands. I think it's pretty tough to do that. So what I did is I used this hairband, all right? Hair elastic. You can use like a regular elastic too. And we're going to put it over the mouth of this bottle. And we're going to make a second knot like this. All right? And I pull it down all the way here. Make sure this is nice and stretched out. All right? So I would even pull the material bit when you have the hairband on. And I'll put it just below like that. So I'm going to stand up while I do this, just so I don't make a mess in case anything doesn't go wrong. And we're going to basically replicate that other experiment that we had done. So what you do is you take your flat card. I'm going to stand up. All right. And we're just going to flip this over. And here's the key point, is you don't want to squeeze the bottle while you do this. I just did, you saw. It's going to mess with the experiment. So it's best to lift it up and try your best not to squeeze it, okay? So now we're going to flip this upside down, like so. All right, and this is going to be a little tough to hold, so you could ask for a second person for help. All right, I'm going to very slowly remove the card. A little bit spilled, no big deal. And as you can see, none of the water's actually fallen through, which is pretty neat. So you'd expect all this water to fall through the holes. Excuse me while I reach for these toothpicks. And it's not. Let's try to see what happens when we place these toothpicks all the way through. All right. Might be a little tough to see. I think you might be able to see them floating all the way to the top. And when you touch it a little bit, I'm going to cheat and tell you what's going on. There's a bit of surface tension, if you remember from the last video, that's holding the water to the surface so that it doesn't fall through. When you're touching it a little bit, what you're doing is you're breaking that surface tension and a little bit of water is falling through. But because we have a lot of water and a small opening, the surface tension comes right back. So let me just put a couple more in. I think we can see that passing through. And if you want to break this surface tension, this is a key actually. You just slightly tilt it. You bring it back actually. So that tension's actually pulling and pointing upwards and counter-reacting gravity going downwards. So if you tilt it, it's not there. All right, folks, there's just some really neat simple. One or two of them were a little complicated activities. I thought they were interesting because we were able to pull ideas that we had used previously in previous videos and show them to you maybe in different ways, and I think pull them together. So I'd asked you to think about some things such as forces, cohesion, adhesion, things I've talked about before, surface tension, forces. So maybe I'll explain why I said think about those as you're doing the activities. And we'll start with the first one. So the first one that we did is that we were able to transfer water over from this cup to this cup from this string. And yeah, you could have just poured it in without the string, but that wouldn't have been fun. Somehow we were able to do so and carry water over just on this one material. So what we did is that we wet the string. So the string itself was full of a bit of water. And what we did is we lifted one of the cups so that it's at an angle. We pulled the string nice and taut so it's very, very tight. So this made a very rigid material. And we allowed water to transfer from this glass to this glass because of the property of adhesion. And what that is, as I said before, is that water likes to stick to one another. If you've ever poured a little bit of water on a glass, put a little bit of water on your mat maybe. I don't know if you can see it. If you can, it's no big deal. When you pour a little bit of water on, it sticks together. And even though it's a weird, strange shape, you pour water anywhere, they still stick together. And that's because all the water molecules, they want to attract to the other water molecules. And we did that. So we made that happen, and we made that happen by making the water stick to one another as it traveled along this string because the string was able to absorb that water. Okay? Pretty neat. Let me put this to the side. I believe the second thing we talked about was this activity where we filled this glass with water and we placed different shapes and colors behind the glass that was filled with water. And for some reason, the images appeared differently, right? So that's a little bit strange, but when you have a glass filled with water, light's coming in through the water in all different directions, but specifically the light that you see is coming from a camera that's placed in front of me. So what you see light coming through, and it passes through the water because it passes through everything. That's why we can see anything. And when it passes through the water, it does something called refract. It refracts. And specifically, it refracts in a certain way, which means it bends, and it bends the light that comes through the water and distorts the pattern. And it distorted in a way where it's actually opposite, where when the light passed through, it refracted so that it changed, it bent, and then as the light then reflected back at you, it was reflected back in an opposite direction. Excuse me, I think a motorcycle just sped by. Let me repeat that. So we had light coming in through the water, it refracted differently than it would in the air. It refracts differently in the water, distorts the image, and then it reflects back at you, opposite. And we saw that with different patterns. And I had shown you this circle because this is a very symmetrical, if it was a perfect circle, it would be a very symmetrical image where even when reflected back, it's exactly the same. So I was trying to make you think the opposite there, but that was a bit neat. And we even saw that with this board, with the two different colors. We saw the black and the yellow. That was my tea kettle going off. Thank you. That was my roommate. My tea kettle was just going nuts. I forgot about that. And we even used that with colors, as I said. It was pretty neat. We actually saw it flip opposite underneath it. So there's that activity. And some other things we talked about, I think I said surface tension, right? So when you just take your card and you place it on, you're able to maybe balance the card a little bit, right? But as soon as you add weight, it falls right over. Well, why is that? Well, when you place a quarter on, this quarter has a little bit of weight, right? And that weight, due to the force of gravity, falls downwards. And because there's nothing on this end to counteract that, it continues to fall. But when we filled this to the rim with water, what we did is we actually took advantage of the surface tension. When the water was filled to the rim, the surface tension actually pulled on that card. So when it pulled on that card downwards, this way, it pulled it so much that it was able to balance the quarter. It's kind of like this. It's kind of like almost as if I'm pushing down on the card now. It's kind of the same idea. Think of the same thing as the water adding tension, pulling on that card, pulling tension on that card. And that's what happened. And if you put too much weight on this end, there's not enough surface tension, and then it falls over and it breaks. All right? And the coolest one, in my opinion, I liked, was this one here. Honestly, I did not believe that, I thought these holes were far too big. Grace actually proved to me that they weren't, and Grace tried to convince me. I said, no, it's not gonna happen, but she was right, and we were able to figure it out. So we kind of a similar idea. We filled it to the rim with water, and we have this net here. And this net, excuse me, there goes my hairband, when pulled tight, formed surface tension because of the water. The water also is cohesive. It wants to form to one another, and it does so at the surface. So when we flipped it over, that surface tension counter-reacted the force of gravity. So we have the force of gravity pulling it down, and then we had the surface tension upwards. And that balanced it. And then we were able to place a toothpick through the mesh, and once it passed through the surface, it then floated to the top because it was less dense. All right? So I think there's just some pretty cool properties of water. It was a little bit of like a manipulation almost, and I think it summed up some ideas well, some ideas we've talked about in the past, so I hope you enjoyed them. Thank you.